All right, here's one of the classic calculus questions about derivatives, which is finding the equation of a tangent line. Whenever I see these questions, I always start with my general linear equation in point-slope form, because that really does tell me the things that I know that I'm going to have to find in this question, specifically the point on the graph and the slope on the graph. So to begin with the point, this is always found by using the actual function you're given, which is the square root of x minus x. Since the problem states to plug in x equals 9, well, that means we're going to be plugging in 9 into this equation. So specifically, f of 9 would be equal to the square root of 9 minus 9, which, if you calculate this correctly, gives you 3 minus 9, or in other words, negative 6. So what does this tell us about the point on this graph? The point itself is 9 comma negative 6. So that's valuable for a lot of reasons. First of all, we know that x1 is a 9. We also know that the y value is a negative 6, which gives us a y plus 6 over on the left-hand side. Now, the far more interesting thing about this question is how to find the slope of this tangent line. So in order to do that, we need the derivative f prime of x. Now, the thing is about this question is that f of x is given to us as the square root of x minus x. So before I take the derivative of this problem, it can be helpful to actually rewrite this function as x to the 1/2 minus x. Now, one of the most common issues that I see in AP Calculus students is after they've taken square root of x and turned it into x to the 1/2, they think that that's actually the first derivative. It's not. It's the original function itself. So notice that this function that I've written isn't the derivative of our function. It is just the original f of x that we have. So if now you're going to find the derivative f prime of x, let's use the power rule on the given function now, which gives us 1/2 times x to the negative 1/2 minus 1. So converting this would give us 1 over 2 x to the 1/2 minus 1, or fully simplified, 1 over 2 root x minus 1. So just like we did before, we're going to plug something into this derivative, which means we'll take the x value of 9, plug it into our derivative, and notice what we get, a calculation that'll give us our slope. So this is 1 over 2 times 3 minus 1. This is 1 over 6 minus 1. This is actually a negative 5 over 6. So this is our slope of our tangent line at x equals 9. The slope is negative 5 over 6. So finally, that's going to go here, which now gives us a way to write down our final answer. Our tangent line equation is y equals negative 5 over 6 times the quantity x minus 9, and we'll subtract 6 from both sides to get a minus 6. So there's the equation of our tangent line. Hope that was helpful. If you want some practice writing equations of tangent lines, try writing the equation of a tangent line to each of these two functions at the given x value. And good luck.